to discuss about some computer vision and image processing techniques and their applications. So, anyone knows what is computer vision? So, what is computer vision, dear participants? What is the difference between computer vision and image processing? Okay, no problem. So, here I will explain about the computer visions. So computer vision is a field of artificial intelligence. So that enables the machines to interpret and make decisions based on the visual data. Suppose like our human, how we are seeing the objects. Suppose if you see any object, then we will analyze that object, and after that you can take some decisions. So like that our computer vision also it works. So suppose my input is some image, so then the computer vision what it will do, so it will analyze the image, it will analysis the image, and it will take the decisions. So the main objective of computer vision is to build a machine so that it can process and interpret the images and videos just like our human visual system does. So the importance of the computer vision is, so this computer vision we will apply in many domains, in various domains, in the healthcare and in the security and robotics and autonomous vehicles. In the healthcare means, suppose you want to identify any disease, or uh, you want to segment any disease, so for that purpose we are using the computer visions. And in the security purposes, so for biometric purpose, so we are using the computer visions. And in the robotics also we are using the concepts of computer visions. And at the same time autonomous vehicles, so moving any cars or any objects, so that you want to detect, then we are using the concept of computer visions. The role of the artificial intelligences help bridge the gap between human vision and machine interpretations. So here the historical background is, so early development from the image processing in the year of 1960s to deep learning, so till now the 2010. So there are so many methods came. So those methods we are going to discuss here. So evaluation is, so from the traditional image processing to deep learning based. So all methods we are using the computer visions. So the interdisciplinary field is, so integrates the concepts from machine learning, neuroscience, and computational photography. So these are the interdisciplinary field of computer visions. So here you can see this is the diagram. So this is the human vision systems. So just I want to see any image. So then our brain will process that image, and after that we will take some intelligent decisions. So like that computer vision also it will work. Suppose you want to capture any image, or you can capture the image acquisitions. Then after that we want to apply some image processing techniques. So pre-processing we are applying. Either you want to remove the noise, or you want to enhancement the image, or you want to compress the image. So here we are using some image processing techniques. So after that again I am applying the pattern recognition and artificial intelligence algorithms to make the decision making. So in this way the computer the vision will works like our human vision systems. So in the case of computer vision, we have the camera, and there may be a single camera or maybe a multiple cameras for an image or video acquisition. So here maybe one camera or multiple cameras to acquire the image, and after that so we are doing some pre-processing. So in the pre-processing, so after that we are applying the some pattern recognition and artificial algorithms, so for decision making. So you can see the similarity between the human visual systems, and this is the computer vision system. So this is the human vision system. So like that our computer vision will works. So the difference between image processing, computer vision, and computer graphics. So here I will clarify your doubts. So because here the main difference between the computer vision, image processing, and computer graphics is, so here my input in the computer vision, so input is image and output is interpretations. Suppose I have given one image, so then So the output is interpretation. Interpretation is nothing but either image analysis or image interpretations or scene understanding. These are the examples of the computer vision. Now coming to the image processing, suppose my input is image, definitely you will get the output is image. So example of the image processing is so image recovery and image reconstructions and image visualizations and image supervisualization and image compressions. So these all will come under the image processing. And coming to the computer graphics. So here the computer graphics input is scene representations and the output is image. So here scene representation means, so suppose I have given any model. So for that model, I have given some scene representation. Then I will get the output is image. So that is the computer graphics. So this is the difference between computer vision, image processing, and computer. In the case of computer graphics, so my input is the model, and so from the model, so I have to generate the image. So you can see the distinction between image processing and computer graphics and computer visions. So this is the difference between computer vision, image processing, and these three are not equal. So here you can see the difference between computer vision and computer graphics. So here I have given two images. So here image and here I have given one model. So from image to I have want to analysis. So that is called as computer vision. Suppose I have the model is input and I want to get the synthesis, then I will get some image is the output. So that is called as computer graphics. So this is the difference between so computer vision and computer graphics. So in synthesis phase, if the model is available, if I can generate the image from the model, so that is called as synthesis. So here my input is image and I will generate some model. So that is called as so analysis phase. So that will call as computer vision. So here coming to the related disciplines. So some of the related disciplines of computer visions. So computer graphics, artificial intelligence, machine learning, cognitive sciences, algorithms, and image processing. So the computer vision is related to all the fields. So computer vision related to the machine learning, and computer vision is intersection with the cognitive science, and computer vision also will use some algorithms, and computer vision in image processing we have will combinations, and computer vision graphics and computer vision artificial intelligence. So the computer vision will use all the fields. So this is the related disciplines. Now coming to the computer visions. So the fundamental steps. So here my input here. So input is the image. So this is my input. So for this input, I want to apply some image processing and segmentation techniques. So means image processing means if any noise is there in the image or any blur is there in the image, so that thus I want to remove. And after that, I want to segment any area, then you can segment. So though after that, the segmented area I will give to the feature extraction. Then feature extraction, what it will do, generate? It will generate the feature vectors. So these based on these feature vectors, so I am do the some classification techniques. So that is called as object type. So that is the object. This is the image analysis of the computer visions. So coming to the advanced applications of computer visions. So these are the different techniques. These are the different applications. So first one is object detection and recognitions. So suppose I have given some images. So in that image, I want to identify and classify the objects in images and videos. So after that, so this detection and recognition we will use in the smart surveillance and traffic monitoring and biometric authentication. So this purpose we are using the object detection and recognition. And next the application is face recognition. So this face recognition we will use in the security systems and mobile authentications and surveillances. So these places we are using the face recognitions. And next coming to the autonomous vehicles. So I want to automatically I want to detect the some obstacles and pedestrians and traffic signals. So these computer visions I want to use. And next coming to the this computer vision we can will use in the medical image analysis and this is diagnosis. So so this will help into the diagnosis so tumor detections and X-ray and MRI analysis. So you want to do, then you want to use the medical analysis and diagnosis, disease diagnosis. So next one is the optical character recognitions. So optical character recognition means so converts printed or handwritten text into the digital format. So for doing this one, so here we are using the concept is optical character recognition. So the converts the image of a text into the machine readable format. So for some business automation, so for that purpose we are using the optical character recognitions. And next one is the augmented reality and virtual realities. So here the virtual reality means ensure that you experience in the gaming and training simulations. And next coming to the another application is so the satellite image analysis. So from the satellite when we will capture the images, so those images maybe applied on the agriculture or climate change monitoring or disaster management. So for that purpose we are taking the image from the satellite. And next one is the application is industrial automations. So here well quality control purpose. So we are using, and next one is defect detection. So any item may be defected. So for that purpose, you want to check. Then you want to use the computer vision and robotics automations in manufacturing. So there also want to use the computer visions. And next, there we are using into the smart surveillance systems. So enhancing the security with real-time monitoring and anomaly detections. So the computer vision we are using. And next, this computer vision we are using in the field of agriculture and remote sensing. Suppose we have some craft agriculture some images. So in that so you want to detect the crop healthy or some unhealthy. So for that purpose, so we are cropping the images, and after that we will apply some models. Then we can check that so the crop is healthy or unhealthy. And next one is the land use assessment. So there also we'll use the computer visions. And next one is for retail and e-commerce applications. We are using the computer vision techniques. So next one is the manufacturing and industrial quality control. There also we'll use the computer visions. So automated defect detection using the computer visions. So these are the applications we are using the concept of computer vision. And next one is key techniques in computer visions. So the first technique is so image pre-processing. Image processing means enhance the, suppose I have taken any, I have captured the image. So that image is in the low resolution image. To enhance that image, so we will use some filters. So and suppose the image you want to segment any part, so then you use the some edge detection methods. And after that you want to do the feature extractions. So the feature extraction use is so identify the important aspects of the images. So what are the important things you want to extract? So those things it will extract. So after that, so that will give to the object detections. Then object detections use is so identify and classify the objects. So these are the different object detection algorithms: YOLO, SSD, and faster RCNN. So these are the different algorithms. YOLO means you look only once, and SSD means so single shot multitask detectors algorithms. And another one is the faster RCNs. So faster region based convolution neural network. So these are the different algorithms we are using for the object detections. So the identifying and labeling the objects within the image. And next coming to the segmentations. Segmentation means so divide the image into meaningful parts. So like so which area you want to interest. So that region of the interest. So the segmentation we will do. So after that we will apply some deep learning based approaches. So in the deep learning approach based here we use convolution neural networks for the complex vision tasks. So these are the different techniques of the computer visions. And next one is so image reconstructions. So image reconstruction means so used some in applications like super resolution and noise reductions. So there we are using the image reconstruction. And next one is the anomaly detections. So identifies some outliers in visual data for security and industrial applications. So we are using the computer regions. And next one is you want to convert from the 2D to 3D or from 3D to 2D. So we will use the 3D computer visions. And next one is the multimodal visions. So integrating the visual data with the text and sound and other modalities. So we are using the concept of computer visions. And next one is the another technique is few shot or zero shot learning. So enabling the models to recognize the objects with minimal training examples. So these are the key techniques in the computer visions. So next, so now we will go for the some elaboration about how the object will detect and what are the methods are there and how those object detection and recognitions. So the object detection means so locating the objects in an image and drawing the bounding boxes. So suppose the image content there are so many objects. So which object you are detecting? So those objects were drawing with the bounding boxes. And object recognition means so classifying the detected objects into predefined categories. So that object is either cat or a dog or horse. So what type of that object? So it will give the it will recognize the object. So that is called as object recognitions. So here example of the visualization is so a diagram showing an image with bounding boxes and labeled as dog and car. So suppose the image contains so dog is there means so it will give the name as dog, it will label as a dog. And suppose the image contains car is there, so the image name will give the label as car. So the applications of this object detection and recognition is so main is autonomous cars. So detecting some pedestrians and traffic lights. So for that purpose, we are using the object detection and recognitions. And next, this application we will use in the healthcare also. So you want to detect some tumor detections in the medical imaging. So suppose in the early stage, if you not detect the some tumors or any disease, so then it is a severe for the health. Make sometimes may die the person also. So for that purpose, so early detection is early is important. And next, the application is some surveillance. So you want to recognize the some face and enable the detections. So for that purpose, we are using the objective detection and recognition. And next one is the retail purpose. So smart checkout systems we are using. So for the object detection and so here I have mentioned that object detection versus image classification. So the first I am doing the some classification. So here in this first image contains cat image is there. So this cat image and next one is the another image. So here I am what doing so classification plus localizations. So here we are uh, drawing the box rectangular box. So this box we are doing the localizations and both combinations so that we are doing the object detections. So here in this image contains some cat image there and dog image is there and next duck image is also there. So it will give the labels. So like that, so the object detection versus so the image classifications we can do. And next one is the coming to the object detection versus segmentations. So here object detection plus semantic segmentation is equal to the instance segmentation. So first image you can see that so the image contains some object we are doing the object detections. So here the image contains so three horse are there. So that's why the first we are drawing the box and next this is the rectangular box and next another dog we are drawing the rectangle. So this is the classify plus localizations. So that is called as object detections. So after that, so we are here segmentation means so the we are drawing the homogeneous regions. So this is the homogeneous regions. So this is the one homogeneous regions and this is the another homogeneous regions. So it means the pixel values are similar to the same. That is called as homogeneous region. So after that, this combination of the object detection plus semantic segmentation is called as the instance segmentation. So here the we are detecting the edges and we are segmenting the first house and second house and the third house. So this is called as image segmentations. So till now you have any doubts? So everyone understand the object detections and image classification and image segmentations. Hello. Okay, no doubts. So I will move to, so here, so to detect
Somebody
this,
asking, sir, somebody asking which is the best technique to detect cancer.
that only
That
they are
question is in
asking.
chat box.
Okay, okay. So for object detections, we are explaining the models. So so these are the some traditional methods. So the first traditional methods for the object detection is so handcrafted feature extractions. So in that context, we have the two methods. So histogram oriented gradients and scale event feature transforms. And next one is the algorithm is so hard cascades are early phase detection used in the OpenCV, and sliding window approach detects the objects by moving a small window over the entire image. So these are the two approaches, and the limitation of these two approaches is so heavily reliance on the feature engineering and ineffective with complex shapes and clustered backgrounds and computationally expensive for the large scale of images. So these are the drawbacks. So to overcome these drawbacks, so we are going to the apply some deep deep learning models. So these are the latest models for the object detection models. So the first one is two-stage detectors. So this is the RCN series. So extract regions proposals then and the classify with the CNN models. And another approach is the faster region convolution neural networks. So combine the region proposal generations with CNN for better speed. And this use case is so high precision but slower in the medical images. So the another one is the another types is one stage detectors. So here we have the YOLO and another one is the SSD. So YOLO means you only look once. So process the images in one pass, and the application is the YOLO is in the real time detections because droner systems. So here YOLO it will works very fast, but the accuracy will be less. So that's why we are using the latest model is the single shot detectors, and this year we are using the faster RCN also. So this is single shot detector. So the accuracy increase and speed also will increase better compared to the other existing models. So these are the a side by side in comparison of RCN versus YOLO on the same image. So these are the next one is the challenge of this object detection is so dataset bias and limitations. And next one is the adversarial attacks. So this is also one of the drawback. And next one is the computational demands. So these are the relevant generalization. So these are the challenges of the still is there, and the future direction is so you want anyone want to work on the object detection, so they can do the enhance the interpretability, and they can do the so leveraging the edge computing, and they can do the integration with the multimodals. So example is so text plus image, so both they can detect. And next one is the future direction is improve the energy efficiency in the AI models. So these are the future directions. And so the some data set also some problem is there. So anyone want to improve the data set, so you can improve. So these are the future directions of the object detection. And next, coming to the conclusions, so the importance of new architectures in achieving the better accuracy, speed, and scalability. So these are the main use of the object detection. So if you want to improve any architectures, so it will achieve the better accuracy, speed, and scalability. So then we can tell that so the given method is better. So next, coming to the digital image processing. So a digital image represents in the two-dimensional image as a finite set of digital values called picture elements or pixel values. Suppose I want to represent any image in the two-dimensional arrays. So that image we have the x-axis and y-axis, and this image will represent in the numbers. So those numbers we will call as pixels. So the if you want to represent any image in the digital format, so that is called as the will represent in the numbers. So these pixel values typically representing the gray level values and colors and what is the height and what is the opacity, etc. So digitization implies that the digital image is an approximation of real scene. So this is the so digital image processing focus on only two major tasks. So the one is the improvement of pictorial information for human interpretations. So the processing of image data for storage and transmissions and representation for autonomous machines perceptions. So how this image processing it will works. So you want to capture any image. So here I have capture the image, and this capturing the image with the camera, and after that I have sent to the some digital processing systems. So this digital processing systems, so it will remove the so what which you want to segment the image or you want to craft the image. So that thing only you want to process the image. So here we are taking only dropping the water. So that only I want to interest. So that image only we have cropped. So like that the image processing will works. So in the above figure, so an image been captured by a camera and has been sent to some digital systems. So to remove all the other details, so whatever the unnecessary details are there, so those details were removed and just focus on water drop by the zooming it in such a way that the quality of the image remains the same. So only our quality of the image will be the same. And next, coming to the key stages in the digital image processing. So the digital image processing, we have some different techniques has been explored, and they are now used for all kinds of tasks in all kinds of areas. So first one is the image restorations, and next the area is morphological processing, and medical visualization, image enhancement, image acquisitions, and image compressions, and image segmentation, and object recognitions, and representation and descriptions, and color image processing, and industrial inflections. So these are all the areas we are working with the help of the image. So image restoration means suppose I have some images. So those images are corrupted by some noise or blur. So then that image will not see the properly. So for that purpose, either in the medical field or in the agriculture field or in the real-time application images, so the images are corrupted with noise or blur. So that image we cannot see that properly. So for that purpose, so some filter is required to remove the unwanted noise or blur. So next one is the morphological processing, and in this morphological processing, so what are the images are important? So those things we want to do. And next one is the medical visualizations. So in our daily life, we are using all the scannings, X-ray or MRI or CT scan or so many types of images. So we are scanning in our daily life. So those all the images are corrupted with some noise and blur. So once the noise and blur will be added into the image, so doctors so they cannot analyze the image. So for that purpose, so some uh, so for that purpose, some medical visualization is required. So then, so it will be show clarity. And next coming to the image enhancement. So image enhancement means so if we have the some image, so that image some details are hidden, and those features we are not able to see. So those features you want to enhance, then you use the concept of image enhancement techniques. And next, the concept is image acquisitions. This image acquisition means, so how we'll capture the image, because how we'll take the X-ray images and how we'll take the MRI scans or CT scans or some ultrasound images. So how we will take these images? Suppose and next one, the concept is image compressions. Image compression means, suppose we have some large size of the image, so how that image we want to compress, and how that compression image without losing the meaningful impressions, meaningful the data. So how we will compress that image. So that is also main challenge in the digital image processing. And next one is the, just now we have discussed about the email segmentations. So image segmentation means, so what, which area you want to segment. So what we have given the image, in the image contents there are so many objects. So what are the objects you want to segment? You want to segment some tumors, or you want to segment some brain tumor, or you want to segment uh, uh, cancers. So different segmentations are there. Or you want to segment any type of some kidney diseases, or you want to segment some liver diseases, or you want to segment any type of diseases. So for that purpose we are using the segmentation concepts. And next, coming to the object recognitions. So whatever we have segmented the object, whatever the object we have detected, and that object is also what type. So that is the what type of classification. So that is the which type. So the, because one image, one disease content, there are so many types. So which type, which class that belongs. And next one is to the representations and descriptions, how that image we are representing, and how that we are deriving the descriptions. And next one is coming to the till now we have discussed about some grayscale images. And next one is the color image processing. So color image processing means we have here three channels, R and red and green and blue. So that is the RGB image we'll call. So how this color images will process. And next one is industrial infections. So we have how to any object is damaged, how we will detect that objects. So those things we will do in the and come into the digital image process. And next, coming to the some image restorations. So why this image restoration is required? So the process of recovering a degraded image to its original quality. So typically deals with the image blurring and noise removal and a resolution of the enhancement. So though all concepts will work on the image restorations. So the why the importance of the image restoration means, so the coming to the medical imaging, so enhances the diagnostic tools by improving the quality of MRI or CT or X-ray or some ultrasound images. So because, so while taking this, all the images contains so noise and blur. So once the image contains noise and blur are there in that, so we cannot do the diagnostic properly. So for that purpose, so some restoration is required in the medical imaging. And next one is the in the surveillance field. So help the clarify low quality footage in the security systems. So any vehicles we are moving, and that purpose, suppose we have captured the image, so that moving objects, there is no quality of the image, and that the image is degraded with some low quality. So to enhance that, you want to restore the image, you want to apply the some image restoration technique. And this image restoration is also we are applying into to the satellite imaging. So while capturing the satellite images, because the satellite images are very far from where taking the images, so these are the these images we can take from the some crafts images, some in the aerial and some aerial images. So once these images are taken from the so far, some underwater images also. So once these underwater images, once we have captured the image, so these images are very blur and noise. So to remove this noise and blur, so we have to apply some image restoration techniques. And next, the in the field of photography and media. So in this field also we are using the image restoration techniques, because we have some any old photo or any some that photo is some damage. to enhance that restore the photo, so then we'll use some image restoration technique. So here the challenges in the image restoration is, so main is the because we have different types of noises. So here suppose in the real time images, so the we have some different types of noises. So the one is Gaussian noise, another one is salt and pepper noise, and speckle noise and gamma noise, and these are the different types of noise. So to capture this, because all noise not stored into the same images, because Gaussian noise will be stored into the some real-time images, and salt and pepper also it will so depends on the situations, and this specular noise will appear in the medical images. So here we have two types of noises. One is the edited noise, another one is the multiplicative noise. So edited noise means, so what are the noises we are adding, so those noise we are adding to the original image, so that is called as additive noise. Multiplicative noise means if you take any some noise, some random noise, so thus we are multiplying with the original image, so then we will get some degraded image. So that degraded image is called as some noisy image. So and once this speckle noise is present in the image, so it is very difficult to analysis of that image. So for that purpose some image restoration techniques is required. And next one is the image degradations. So how this image will be degraded, because so sometimes the moving object we are taking some motion blur, so that time we are taking the object, so some that time, so this blur will be added. And sometimes so some deep focus, so out of the focus images we are capturing the image, so that time so this blur will be added to the image. And sometimes we are compressing some artifacts, so that time so the image will be degraded. So to degrade these images, so we have some different techniques, so those different techniques we will discuss here. So the complexity require high computational power, especially for the high resolution, because so some images 252 by 252 images are there, and some images size is 512 by 52, and some images size is 1024 by 1024. So you have the high resolution image, and suppose you have the dimension is more, so then the some high computational power is required. So how that we will handle, we will see here from some actually there are some existing methods, some traditional approaches are there. So first starting, so to remove the noise or blur, so they have used the median filters. So here median filter means, so here remove the salt and pepper noise, and the median value is in the window is used to replace each pixel. Here we are taking one window some 3 by 3 or 5 by 5. So this with median filters, so we are removing the noise. So the salt and pepper noise is removing easy, but the speckle noise and Gaussian noise is removed the very difficult. So for that purpose, so next they use the Wiener filters. So based on these Wiener filters, so here they have used the concept is local image statistics to reduce the noise, and they are preserving the edges. Because once we are removing the noise, then the our structure of the image cannot be go, because our medical images means, so the very fine details will be preserved. Fine details are present. So if you remove the noise, then it will the edge also sometimes it will be removed. So the edges will remove means, so we cannot identify the diseases properly. So for that purpose, we want to care more better algorithms. So here is in the window filters, so they adopt the local image variations. And next coming to the blind deconvolutions. So here blind deconvolution means, so they have used the blur from the images with the blur kernel functions. And next, and it estimates the both original image and the blur kernel. So the limitation of this traditional approach is inefficiency in handling some complex noise. With less noise, so these methods are working better. Suppose my noise level is increasing, so then it is very difficult to handle these traditional methods. So difficulty in recovering the fine details in imaging with large degradations. So fixed these assumptions. So these methods are based on only certain assumptions like noise type or blur type. And next, coming to the some deep learning in the image restorations. So here we have some deep learning methods. So these are the methods so to remove the noise better and compared to the some traditional methods. So the first one is the use of the deep learning model. So particularly the convolution neural networks. So this will work on the removing the noise and preserve the edges. And the advantage of this method is so ability to handle wide variety of degradations, so learn complex features and generalize to different kinds of noises. So because we have some different noises, so Gaussian noise and speckle noise, gamma noise. So to handle this noise, so here we are applying the convolution neural network. So the drawback with the convolution neural network method is so it requires the large of data. But in the previous methods, so they require only less data. So that is the difference between the traditional methods and the deep learning approaches. In the first one here is uh, convolution neural networks. So in the convolution, CNN are particularly good at learning spatial hierarchies of features in the images. So example here we are using the denoising convolution neural networks, a deep network trained to remove the noise. So here, suppose we have the speckle noise. So speckle noise is the multiplicative noise. To remove this noise, so because they are multiplying with the image, so for that very difficult to remove. So for that purpose, here we are using the some CNN models. And next, the latest model is the auto encoders. So by using this auto encoders model, so the unsupervised model learn a compressed representation of image and can be used for restoring the missing details. Or and these methods used is for the removing the noise. And next, after that, the next model is generative adversarial networks. So here GAN contains so GAN contains two things are there. One is the discriminator and another one is the generators. So here we have the two things. So one is the discriminator and another is the generator. So generator always generate the image. Generator always generate the image. Suppose I have generated the noisy image, and this image will send to the some discriminator, and the discriminator it will check that with the some original image. So it will not matching. So if the image the discriminator will found some fake image, then again it will send back to the generator. Again generator it will learn the image and it will give to the some discriminator. So like that, so the generator and discriminator it will both they learn and it will give the denoised image. So properly here the noise will be removed from the images. So the advantage of this deep learning techniques is so learnable features. So the models learn feature directly from the data and improve the flexibility. So that is the use of the deep learning models. And next the use is adaptability. So better at adapting to the real world noisy and blur images. So the another one is end-to-end training. So here we are using the concept of neural network can be trained on the entire restoration process. So these are the uses of the images. So these are the different techniques to remove the image restorations. And next one is the latest that some deep learning models are there. So another one is the unit for the image resolution. So this unit architectures so popular for the deep learning model architecture. So particularly in the medical images. So it consists of two things. One is the encoder and another one is the decoder the structures with the skip connections. So this encoder will encode the images and decoder will use the some decode the image. And here we are using the concept is some skip connections. These skip connections, so the use is so the unwanted things is so it will not train the models. So that's why you are using the concept is skip connection. So which allow the network to retain the both high level features and low level features. because some image contains so the what are the low level features and you want to preserve some high level features. So here we are using the concept of unit. So this unit also you can use in the segmentation and some classification and for the image restoration and for image enhancement. So we are using the unit architectures. And next one is the denoising convolution neural networks. So this method uses so a deep convolution neural network specifically designed for the image denoising. So it works by learning the residual map between the noisy and the clean image. So which is subtracted from the noisy input to recover the original image. So because they have some original image, so compared to the original image, so the noise image will be compared. So the noise image and so the last function is more. So again one more time it will go to the train the image. So like that. So once the image is come to the original image, so then that time it will stop. Until that, so the convolution neural network it will be train the model. And the another technique is so the drawback of this CNN model is so it requires very large of data. Sometimes, suppose if you not get the large data, then it is very difficult because so real time images will get, but some medical images, suppose in the lung images or some liver images, some cancer images, so we will get very few images. And sometimes, so the persons also they will not give their data because so they will maintain some confidentials. So that's why we will not get the large data sets. So for that purpose, so they have used the concept is deep image clears. So this is the another new concept which is proposed in the year of 2018. So deep image clear. So here no need of the large data set. With a single image also we can train the our deep learning models. So that's why we will call as deep image clear. So a novel approach where the neural network itself is to be clear for restoring the images. So deep does not require any pre-trained networks or data sets, making it suitable for real-time restoration of the images. So that is the use of the deep image clears. So this deep image clear not only for restore the image. So this deep image clear model also it will work on the super resolutions and it is also work on the some image imprinting problems. So this if you don't have the large data set, then you can go for this deep image cleaner techniques. Next, coming to the some GAN models. So here the some specialized GANs have been designed for the image restoration by training the generator on a combination of noisy and blurred and low resolution images. So these models can restore the high quality images with remarkable details to recovery of the images. So GAN model are also giving the better results for the image restorations. So the application of the image restorations. So this medical imaging we are using. So MRI or CT scan restoration for better diagnosis. We are using the concept of image restoration. And next, the purpose of the satellite imaging. So restore the satellite images for environmental monitoring and so agriculture analysis and urban planning. So to whenever we are taking some satellite images, so this agriculture images. So because we are taking from the so very far. So once you are taking some defocus images means, so definitely some motion blur will be added to the image, and that image contains some blur will be there. So to remove that blur, so then we are using some GAN based methods or auto encoder based methods, or you can use some convolution neural network methods. And next, the in the surveillance and security purpose also we are using the image restoration techniques. And another one is the some facial recognitions. So sometimes in the surveillance purpose, weather is not good, and suppose low light we have, so our low resolution is there. So to detect that face, so we want to use the some image restoration techniques. And another field is so we are using the art and cultural heritage restoration. So the image restoration technique used to digitize the restore old or damaged artwork and enhance the historical document preservation, such as depending on the type of degradations. So these are the application of the image restorations. And next, coming to the some challenges and some future directions. So the challenge of the here is the main is computational complexities. So many state-of-the-art models are required significant computing resources, making them challenging for real-time or large-scale applications. So ongoing research focus on the making these models more efficient through techniques like model compressions. So coming to the generalizations, so models are trained on specific type of noise or blur may not generalize well to other models. So we have some Gaussian blurs and Gaussian motion blurs. So both we cannot apply the same methods. And we have suppose Gaussian noise, and for Gaussian noise I want to apply some different technique. And suppose the gamma noise I want to apply different technique. And for Poisson noise I want to apply different techniques. So we cannot for Rayleigh noise I want to apply some different techniques because each noise follows some different probability density functions. These different probability density functions. So suppose I want to check so the image contains which type of noise is present. Then you can take any homogeneous regions, and this homogeneous region you want to plot or you want to draw the histograms. So these histograms you can compare with the probability density function of gamma noise or relay function or Poisson functions or Gaussian functions. So which curve is matching, which plot is matching, then we can tell that so that image contains so the gamma noise is present with that image contains we can tell that some Poisson noise is present. We can tell that the image contains some relay noise is present. So based on that, you want to apply the different techniques. So, but for all the noise removing, so same method will not proposed. And next, you can propose some generalization model also. And next one is the future direction is more robust and generalized model that works across the multiple restoration tasks. So that type of model also there is a chance to we can also propose. And next one is the ethical concerns. So image restoration has ethical implications, and especially in the field of like forensics. So the here the example is restoring or altering the image could lead to tampering of evidence in the criminal investigators. So these are the problems are there. So to overcome this, so you want to propose some better methods. So next step in the research is combining AI with the traditional image processing technique for hybrid models also propose. And next one is for reinforcement learning for adaptive restoration depending on the type of degradations. So also we can propose. And next coming to the conclusions. So deep learning has a revolutionary image restoration and suppressing the traditional methods in handling complex degradations. Here we have used some unit architectures, denoising convolutional networks and GAN methods, so are proper for the better quality and efficiency and the restoring the images. So these are the better methods. And now coming to the ongoing research is focused on the improving the computational efficiency and generalizations. For suppose we have suppose the method, it will work on the all the type of noises, and you can take the taking the ethical issues. So these methods also we can propose. So you have any doubt in the image restorations? In the area of image restoration, suppose you have any doubt. So here just I have given the overview of the some image restoration techniques, some traditional approaches, and some deep learning based approaches. So with these deep learning based approaches, giving the better results compared to the some statistical methods or some traditional methods. And next coming to the we have discussed some challenges and some future directions. and we have discussed the conclusions. And next, coming to the some image enhancement. So, coming to the introduction to the image enhancement. So, anyone knows what is image enhancement? What is the difference between image restoration and image enhancement? So, image restoration and image enhancement difference is, so image restoration means, so we have the image, so that image is degraded to recover to the original image. So we use the image restoration concept. Image enhancement means, so improve the visualization appearance. So that is called as image enhancement. So what is image enhancement means? So a image enhancement refers to the process of improving the visual appearance of an image to make it more suitable for a particular task. That is the use of the image enhancement. So the goal of this image enhancement is to highlight the important features and improve the contrast and reduce the noise. So both are not same. Image enhancement means different, and image restoration is different. So image enhancement means we have the image, so that image only we are improving the sub visualization appearance. So that is called as image enhancement. So the importance of the image enhancement is it plays a crucial role in the various fields like medical imaging, and this also it will play in the satellite imaging and security and in the media. So helping in the improving the visual quality and interpretability of the images. And coming to the different types of image enhancement. So the where we can handle the special domains, and next one is the frequency domains. So special domains means, so direct manipulation of the pixel values. So that is called as uh, special domains. And frequency domain means, so modifying the frequency components of an image using transforms like Fourier transforms. So image enhancement means, so in the left side, so the image is some contains some not visual is good. So once you apply some image enhancement technique, so you can see that the right side image is, so visual is appearance is good image. So like that we can do, because here you have you can take some small lines are there. So here clearly, so this edge is visible properly. And now coming to some traditional method for the image enhancement. So the first one is some histogram equalizations. So improve the contrast of an image by redistributing the pixel intensity values. So next one is, so make low contrast image appear clearly by spreading out the intensity values across the entire image. So that is the drawback of the histogram equalization. Next, coming to the linear and non-linear contrast stretching. So linear stretching means increase the contrast of an image by linearly stretching the pixel intensity values. And coming to the nonlinear stretchings, use more complex functions to enhance the image contrast based on the local features. But here we are not concentrating on the global features. So that is the problem with the nonlinear contrast stretching. And next here we have applied some filtering techniques also to enhance the image. So here's the low pass filters. So smooth the image by removing the high frequency noise. And if you apply some high pass filtering, so enhance the edges and fine details by removing the low frequency components. So the next coming to the median filters. So this median filter uses, it removes the salt and pepper noise while preserving the edges. So because these filters are removing the noise if noise is present in the image, but sometimes so the edges are not preserved. So these are the drawbacks of this the traditional approaches. Then we will came to the some new approaches. So that is the machine learning and deep learning approaches in the image enhancement. So here deep learning for the image enhancement. So here we have some different techniques. So neural network deep learning methods have shown remarkable performance in the enhancing the image quality, particularly for the denoising and super resolution and deep blurring and inpainting. So the CNN models we are using. And in the super resolution, we are using the SR GAN. Super resolution, SR means super resolution generative adversarial networks. So this method will enhance the image super resolutions compared to the low resolution images. And this next one is image denoising using autoencoders. So here we are using the concept of autoencoders. So can be trained to remove the noise while preserving the important features and enhance the images. And here also we have used the denoising convolutional network for the enhance the images. So here also we have used the GAN models so to enhance the image quality compared to the realistic details, so that we have lost some due to compressions or degradations. So this example is uh, enhance the net for photorealistic image enhancement. So these applications we can use in the different applications. So like in the image resolution, what are the applications are there? So the same application we are using the image enhancement in the medical imaging and the satellite imaging and in the aerial imaging. So we are using the image enhancement techniques, and in the surveillance field and in the photography and entertainment field. So these enhancement techniques we are using. So because suppose our MRI once we have noise is removed, so after that also the image may be not seeing properly. So for that purpose, so you want to use again some image enhancement techniques. So to better visualization purpose, so we are using some enhancement techniques. So one in the medical images like MRI, CT, or X-ray images, or some ultrasound images. So these are the images. So you want to see some hidden details or hidden features. You want to apply some image enhancement techniques. And in the satellite field also, so once we have removed the noise, after removing the noise, the image will not get we are not enhancing the some features. So to enhance those features, so you just apply the some image enhancement techniques also. So then it will give the better visual appearance. So then we can for diagnosis purpose we can use the this image enhancement techniques also. And the challenges for this is, so here also some computational complexity, because this deep learning require more computational resources. So GPU is required because in most of our systems we are using the CPU only. So again, so this is the drawback of the computational complexities. To run any deep learning models, so GPU is required, graphics processing. So next one is some generalization. So because to enhance the some medical images or real images or short images, so some generalization models is required for all the conditions or in the degradations. And next one is noise versus details. So balancing the noise reductions, and also at the same time you want to details preservation is a challenge, or enhancing the image can lead to artifacts. So these are the challenges are there. And next, coming to the future directions. So some efficient models are proposed. So those are the now present research is focused on creating lightweight models for real-time image enhancement on mobile devices like and edge computing. Because whatever the lightweight models you want to propose, so those we can deployment on the mobile devices and the web computing, so easily so users can access, so and easily user can see the what type of disease and what type of uh, cancers, so they can check, and they can check so what type of crop diseases, so in the agriculture field also we can check. And next one is the another one is the multimodal enhancement is required. So combining various enhancement techniques for more comprehensive image improvement. So we can also do some combine some two three models. So we can create one model. So the better future experiment. And next one is the explainability and interpretability. So improving the transparency of deep learning models to understand how interpretations are made. So these are the different models. And next, so almost we have covered the image enhancement techniques. So from the traditional model to the deep learning. So you have any doubt in the image enhancement? sorry. Next, coming to the segmentation area. So, because the segmentation is also, image segmentation is also important. So, just now we have discussed about the how to restore the image and how to enhancement the image, and now how after that enhancement, so then we can go for the segmentations. So, before the segmentation, in the image contains some noise or blur, or you want to enhance the image, so you can use some pre-processing techniques. And next one is the image segmentations. So image segmentation means partitioning an image into the region based on characters. Example, colors or intensity. So based on that, we can segment the images. So this image segmentation, we can go for the application object detections and medical imaging and autonomous vehicles detections. And the challenge here is so complex boundaries and noise and occlusions. So these are the challenges in the image segmentation. So we have traditional segmentation techniques. So the first one is the thresholding techniques. So this based on this thresholding technique, we can classify the pixels and based on their intensity values globally and adaptively. And next one is the edge-based methods. So detect the object boundaries using the operators as a Sobel and Kenny operators. And next the technique is region-based model. So this region growing and splitting the merging the methods. And next one is watershed models. So segment the using gradient descent models, and so these models, the traditional models are not segmenting the proper. So that's why we are going for the deep learning for the image segmentations. So why this deep learning is required? So handle some complex images and automate some feature extractions and high accuracy getting that. So we are using the deep learning models. So the advantage of this the deep learning model is high precision and scalability and reduce the manual interventions. So for that purpose, we are using the deep learning models. So in the deep learning architectures, we have some three fully convolutional neural networks. So this model will use pixelized classification using convolutions. And then another one is the unit architecture. So here also we are using the encoder decoder with skip correction. So commonly we are using this model in the medical imaging for the segmentations. And next one is the segment network. So here also we are using the encoder decoder architecture for accurate segmentation compared to the unit. And next one is the deep lab. So this uses the convolutional networks, so CRFI segmentations. So the advanced deep learning techniques are here. So mask RCNS, so combine the object detection and segmentations. So we are providing the here masks. So with the mask, so we can detect the segments accurately. And next one is we are using the techniques is attention mechanism. So by using these attention mechanisms, so focus on the important image regions. So what are the important regions you want to segment? So those things we can segment. And next one is the GAN. So this GAN models also we can segment the image with the high quality. Next one is so this image segmentation will use in the some medical imagings. So importance in the medical imaging. Suppose you want to do tumor detections. So in the tumor detection, you want to segmentation and help isolate the tumors or lesions in the medical scans. So such as MRI images and CT scans in the X-rays. So you want to detect some tumors, so we can detect the tumor images. And next one is the organ segmentations. So vital for identifying and measuring the size of the organs in diagnostic images. So you want to measure so how much the size the cancer tumor is growing. So to detect that one, so you want to use the some segmentation techniques. And next one is the breast cancer detections. So segmenting the some mammogram to detect the tumors. And next one is the brain tumor segmentation. Also, we are using these techniques. So using deep learning models like UNet to detect some brain tumor in MRI scans. And next one is the lung nodule detections. So this is segmentations in CT scans to identify the monitor the lung cancers. So here this lung cancer will take the CT scans. So the challenges here is this. So variations in the imaging modalities and patient's anatomy and scan quality. So these are the more important. So our quality scanning quality is not good. So we cannot segment them properly. So and next one is the limited annotated data for the training deep learning models in the medical imaging. So here we have the very less data set because brain tumor cancer as a very less and breast cancer the images are very less. So so once the data is less, then you want to apply some augmentation techniques. So these augmentation techniques, so based on the generative adversarial networks. So by using these generative adversarial networks, so if you have the less data set, so you can increase the data set. So by using the GAN models. So after applying the GAN model, so once your data set is large, so then you can apply for that on the some segmentation techniques. So the applications in the medical imaging is so here so in the real time here is so essential for applications like autonomous vehicles, and next one is large scale segmentation of satellite images or city scale data, and challenges is computational power and memory constraints. And this segmentation images we have the some evaluation metrics. The first one is accuracy and precision. So this accuracy measures the how many pixels in the segmented image area correctly identified, and the precision means so assess the proportions of true positive to the total predicted positives. And next one is the another evaluation metric is intersection over unions. So this intersection over union metric uses a critical metric for evaluating the segmentations. It measures the overlap between the predicted segmentation mask and the ground truth mask. So once this is one of the evaluation metrics. And next one is the dice coefficients. So similar to IOU, but it gives more balanced measures between the precision and recall values. And next one is the another accuracy pixel-wise classification. So measures the percentage of the correctly classified pixels. So these are the different metrics for the medical image segmentations. And next coming to the some future directions and conclusions. So here self-supervised learning models is required, and next one is 3D segmentation. So extend to 3D data, example CT scans, and next one is some transfer learning models. You want to tune some fine tune the models and domain specific tasks because we have different images you want to segment. And next one is the explainability. So making segmenting model interpretable, especially in the medical fields. And next coming to the conclusion, so image segmenting is a critical step in many computer vision applications, and advancement in the deep learning significantly improve the accuracy and applicabilities. So here I use the techniques unit and mask RCNN and deep learning architecture with attention mechanisms are at the forefront of the research. So while challenges exist here areas like real-time processing and medical imaging, and future research promise to improve the solution through the methods like self-supervised learning and 3D segmentations. So till now we have more work is going on the 3D data. Next, coming to the some image processing techniques. So here we have some grayscale conversions. So reduce the image complexity for processing. And next one is some we have the some image filtering. So Gaussian and median filters and built-in filter helps in the noise reduction and smoothing the image. And next one is the morphological operators. So these morphological operators, so here we are using the dilations and erosions, and these are used for the image enhancement. And next we have worked on the some histogram equalizations, so to enhance the image contrast for better future extractions. So here we are using some Fourier transfer in the image processing. So from the frequency domain analysis for the filtering and compressing the images. And next we have another technique is super resolution technique. So this super resolution technique is so enhance the some low resolution images using the artificial intelligence. So these are the different some image processing techniques. And coming to the feature extraction methods. So so here there are different feature extraction methods. So first one is the harness corner detections. So detect the corner features in the images And next one is the SAFT, scale invariant feature transform. So extract the key features invariant to the scale and rotations. And the another technique is so some self so speeded up robust features. So faster alternative to shift for the features. And the next one is the ORB, so oriented fast and rotated brief image. So feature efficient feature detections and matching the methods. Another use is histogram of oriented gradient method used for the some object detections, particularly for the pedestrian recognitions. So next one is the Gabber filters. So the used for the feature extractions. So next one is the deep learning approaches. So CNN based approaches. So it will denoise the image and enhance the image, and this use also some segmentations. And next the another approach is some self attention mechanism. So till now the latest models are work is going on the vision transform, so capturing the long range dependencies. So these the existing methods will work only the some local features and global features, not capturing the images. So for that purpose, so now the all work is going on the vision transform. So these vision transform uses it will capture the and it will preserve the local features and as well as global features. So these are the already we have discussed the methods for the object detection methods. And next one is the some image augmentation techniques. We have discussed this one. And coming to the deep learning approaches for in the computer visions. So here we have discussed about the CNN models. So this is the backbone for the computer vision applications. And next one is some transfer learning and pre-trained models using like resident model and efficient and vision transformers. So these are the pre-trained models. And next one is the generative models. So used for the image synthesis and image analysis. And then another technique is vision transformers. So this transform based on the architecture for the improve the vision tasks. And the another model is self-supervised learning. So this learning representation from the unlabeled data. So and next one another method is so zero shot and few shot learning. So recognize the new objects with minimal labeled examples. So the another technique is reinforcement learning in the vision. So applied in the robotics and autonomous navigations. So these are the computer vision techniques. So these are the different. So image classification, object detection, semantics segmentation we have learned, and next one is the instant segmentation and phenotypic segmentation, key point detections. So you want to detect some persons and you evaluate some depth perceptions and image captioning. So these are the 3D object reconstructions. So these are the different computer vision techniques. So next coming to the some computer vision and image processing. These are the combining some studies. So you want to do some smart city projects. So traffic management systems. So utilizing the image processing to enhance the traffic cameras and which are the analyzed by the computer vision for magnetic flow and detecting the incidents. And again, we are applying this both combining the image processing and computer vision in the agriculture field. So to craft the monitoring the systems. So so these are the some automation images. So challenges in the computer vision is main. So data quality and annotations. So need so for large and well labeled data sets. And another one is the in the computer vision is so accumulation in the variability in the lightings. So main effects detection and recognition accuracy. So the another drawback in the challenge in the computer vision is so computational power requirement. So require here high performance GPUs and cloud computing. So next another one is the challenge is so ethical and privacy concerns. So issues with the surveillance, bias, and data securities. And next the another challenge is adversarial attacks. So the another challenge is real-time processing constraints, and another is high resources dependencies. So need for the GPU and TPUs. So to execute the models. And coming to the future of the computer vision is so advancement in the AI and deep learning models. So improve the accuracy and efficiency. And next one is the edge computing in the real-time processing. So reduce the latency for quick decision making. So the another feature of the work in the computer vision is so explainable in the AI systems. So enhance the some transparency and interpretability. So integration with the IoT and 5G networks also. So enabling the smarter and more connected vision applications. So another feature work is so neuromorphic computing. So mimicking the human brain processing for the enhanced efficiency. So another feature work for the computer vision is so cross-modal learnings, combining vision with the text and audio application. So coming to the conclusions, so computer vision is a transferring industries with powerful applications. So ongoing research and advancements are driving further improvements. So AI-driven advancement with further enhance the automation and efficiency and real-world applications. So ethical considerations and responsible AI practices and essential for the widespread adaptations. So the another conclusion is so future development will lead to more robust, efficient, and explainable in the computer vision systems. So thank